Here we are on page 12 with solutions 26 through 34. We're going to use completing the square on these as well. They look a little bit tougher, but we'll be able to do them. Number 26. What I'm going to do is take this 15, half of 6 is 6, squared is 36, so we need a 36 here. Now we could just add 21 to both sides, but I'll do this in two steps. X squared minus 12x, leave a space, equals that negative 15. So we just subtracted 15 over. Now we're going to make this into a perfect square by adding 36, adding 36. We took half of 12, 6, squared it, and 36. What that did was made it so we could write this as x minus 6 altogether squared. It put it into that nice, easy format of square rooting. And that is negative 15 plus 36 is a 21. Now we can square root both sides, plus or minus, and we get x minus 6 equals plus or minus the square root of 21. Square root and squared cancel. Now add 6 to both sides, and we get 6 plus or minus the square root of 21. So that would have been a really nasty one to try to factor into those things. So this is why completing the square is valuable. Number 27. This isn't going to factor, and we would love to have that guy as a 49. So let's take him away right there and write x squared plus 14x equals a negative 2. And let's add in that special number, which makes it a perfect square. And we get, this is x plus 7 squared equals 47. When we square root both sides to get rid of the square, we now have x plus 7 equals plus or minus, oh, don't forget that guy, plus or minus the square root of 47. So subtract 7, and we get x equals negative 7 plus square root of 47, or minus the square root of 47. So we get a number about 14 or just barely above 0 are our two answers there. If you plug that in your calculator, you can see what the decimals are. Does this square root simplify? I don't think so. Number 28. X squared plus 9x plus 11. Ooh, this is kind of a tough one. Half of this is going to be a fraction, but let's do it anyway. Let's try to move that guy over, and so we get x squared plus 9x equals negative 11. Now we're going to add half of 9 squared. So 9 halves squared is 81 fourths. Okay, there we go. So this becomes x plus 9 halves squared equals, this is negative 44 fourths plus 81 fourths. So we end up with positive 35 fourths. Make sure you're okay with that. Negative 44 fourths. And when you add those two, we get positive 35 fourths. So now when we square root both sides, square root with a plus or minus, we get x plus 9 halves equals plus or minus the square root of 35 over, now the square root of 4 is just a 2. It's kind of nice that these will end up being the same denominators. For when we subtract that over, we get x equals negative 9 halves plus or minus the square root of 35 halves. So we could just write it like this. And that's what our two answers will look like. Okay, number 29. We're going to need some room here. Okay, so let's take that guy over there. X squared minus 3x equals a negative 15. Half of 3 is 3 halves. Squared is plus 9 fourths onto both sides. So this allows us to write x minus 3 halves squared equals, this is negative 60 fourths. So negative 60 plus 9, that's negative 51 fourths. So we'll get rid of the square now, and we get x equals 3 halves plus or minus the square root of negative 51 over 2. Ooh, that guy will come out as an I, the negative one, so we'll get x equals 3 plus or minus I squared roots of 51, or square root of 51i, all over 2. Two imaginary numbers there. Number 30. Take the 15 over and we get x squared minus 1/2 x equals a negative 15. Half of that is a fourth, squared is a 16th. So we're going to add 1/16 to both sides. Oh, this is going to look a little ugly, but let's do it. Negative 1/4 altogether squared equals, now this in 16ths is 240. So this is negative 240 plus 1, negative 239 over 16. Square root, plus or minus. X equals 1/4 plus or minus I square root 239 over square root of 16 is 4. Let's make sure we know where each of those came from. Negative under the square root went to an I. 239, pretty sure that doesn't have anything nice that's going to factor out of there. And so we now have x equals 1 plus or minus. Let's write it this way just for kicks. There we go. 1 plus or minus square root of 239 I all over 4. Or you could write that as the 1/4, the a plus bi in the standard form for imaginary numbers, complex numbers. Number 31. Take that 15 over. Boy, that 15's in a lot of them. So we get x squared plus 5/4 x space equals a negative 15. And we're going to add to it, to complete the square, half of this, which would be 5/8. If we take half of 5/4, we times the bottom by 2, and we get 5/8 squared is 25/64. So we get on this side x plus 5/8 altogether squared equals, ooh, this one looks ugly. That turns out to be negative 960/64. So negative 960 plus 25, that's going to be negative 935/64. So now when we square root, plus or minus, we have x equals negative 5/8 plus or minus, negative's going to make an I, square root of 935 over, and square root of 64 is 8. So you could leave it separated like this, or write negative 5 plus or minus the square root of 935 I all over 8. Good deal. So that's the answer to 31. I think 935 is stuck right where it is. We could factor it out and see if that'll simplify, but I don't think it will. And now for number 32. Ooh, now we run into a little bit of an issue here. You'll notice with this 3 here, we can't turn this into a perfect square, so we got to get rid of that 3. So we're going to divide by 3 everywhere, and we get x squared minus 4x plus 5 equals 0. Divide by 3, divide by 3, divide by 3 everywhere. Now this one isn't going to factor because we have to add up to a negative 4. So let's get that guy over there and make a complete square. X squared minus 4x equals a negative 5. Half of negative 4 is negative 2 squared. We're going to have to add 4. Add 4. That allows us to write this as a complete square. Negative 1. And when we square root plus or minus, we get x minus 2 equals plus or minus I. square root of negative 1 is I. Add 2, x equals 2 plus I, 2 minus I, and we have it. Excellent. Number 33. We have the same issue. All the perfect squares that we've done have a leading coefficient of 1. And so this 7 causes issues. We can't make a perfect square. So we divide everything by 7. Oh boy. Well, that guy too, if we want. So we get x squared minus 11 sevenths x, and then put that guy over on the other side, equals negative 4 sevenths. Whew. That's terrible looking. So we're going to take and make a complete square by taking half of that, which is 11/14, and adding it to both sides. The square of that, 121 over 196. Ooh, yuck. That then makes x minus 11/14 squared equal, oh boy, here we go. So this we have to times by 28, times by 28. Oh yeah, that'll get us up there. Yeah, that should do it. So this is, let's do a little scratch work over here. Negative 4 times 28 is negative 122. Negative 122 plus 121. So that's negative 1 over 196. Yeah, oops, let's take those away. Quick, too many equal signs there. Negative 1 over 196. Good. Now we square root, plus or minus, and we get x minus 11/14 equals plus or minus, that's just going to be I on the top and a 14 on the bottom. Isn't that nice that we get denominators that you can take the square root of? So add it over and we get x equals 11 plus or minus I all over the 14, or 11/14 plus or minus 1/14 I. Okay, last one. This one looks like an ugly one. Let's get rid of, let's do it in a different color so we can tell where we are. Number 34, divide by 5, divide by 5, divide by 5. So we get x squared minus 3/5 x, and then move that guy over to the other side so we leave a space, equals negative 1/5. Now let's add in that special number to make that a perfect square. Half of 3/5 is 3/10. Squared would be plus 9/100. Got to do that to both sides of the equation. And we get x squared minus, x minus 3/10 squared equals, now this is negative 20/100. Negative 20/100 plus 9/100 gives us negative 11/100. Square root, plus or minus, x minus 3/10 equals plus or minus, I comes out of there, square root of 11 over square root of 100 is 10. Add that over and we get x equals 3/10 plus or minus square root of 11 over 10 I. Or we could write it as 3 plus or minus I squared of 11 all over 10. Either one of those is fine. Here is your standard form.